bubble sort, sometimes referred to as sinking sort, is a simple sorting algorithm that repeatedly steps through the list, compares adjacent element, and swap them if they are in the wrong order. The pass through the list is repeated until the list is sorted. The algorithm, which is a comparison sort, is named for the way smaller or larger elements bubble to the top of the list.
Selection sort is a simple sorting algorithm. So, sorting algorithm ay isang in-place na nagkakaroon ng comparison base, which is the list or listahan ay nahahati sa two parts, which is the sorted part at the left end and the unsorted part at the right end. Logic. Array is considered into two parts, unsorted and sorted. Selection. Select the lowest element in the remaining array. Swapping. Bring it to the starting position. Counter shift. Change the counter for unsorted array by 1. So this is the example of selection sort. We have a sorted array and unsorted array. 64, 25, 12, 22, and 11. Swap the 64 in unsorted array and 11 in sorted array. And counter shift and selection, we have a 25, 12, 22, and 64. Swap the 25 in unsorted array and 12 in sorted array. Counter shift, we have a 25, 22, 64. So, swap the 25 in unsorted array and 22 in sorted array. Counter shift 25 and 64. Counter shift and 64. Counter shift. So, this is the sorted array. So, this is the code of selection array. Insertion sort is the sorting mechanism where the sorted array is built having one item at a time. So, this is the direction of insertion sort. First, set a marker for the sorted section after the first element. Second, repeat the following until unsorted section is empty. And select the first unsorted element and swap other element to the right to create the correct position and shift the unsorted element. Advance the marker to the right one element. So this is the example. So we have a sorted array and unsorted array. So select the first unsorted element. So 8 and swap, advance the marker. So 5, select, swap, and advance the marker. So 2, swap, and sorted array na siya. So, ulit-ulitin natin hanggang sa maging sorted array siya. Kumbaga, magkakasunod-sunod silang lahat. And 6, and 3. So, magiging sorted yung 3. So, this is the sorted array. So, this is the sample code of insertion sort.
Quick sort is an in-place sorting algorithm developed by British computer scientist Tony Hoare in 1959 and published in 1961. It is still a commonly used algorithm for sorting and implemented. While it can be somewhat faster than merge sort, and about 2 or 3 times faster than heap sort. Quick sort is a divide and conquer algorithm. It works by selecting a pivot element from the array and partitioning the other elements into sub-arrays according to whether they are less than or greater than the pivot. For this reason, it is sometimes called partition exchange sort. The sub-arrays are then sorted recursively. This can be done in place requiring small additional amounts of memory to perform the sorting.
Merge sort. What is merge sort? Is a divide and conquer algorithm. Merge sort is an efficient general purpose and comparison based sorting algorithm. Most implementations produce a stable sort, which means that the order of equal element is the same in the input and the output. There are two functions are involved in this algorithm. The merge function is used for merging two halves. The merge sort function recursively calls itself to divide the array till size become 1. Radix sort. What is radix sort? This algorithm is only used to sort numbers. Sort the numbers from least significant digit to the most significant digit. We use counting sort as a subroutine to sort. The other definition of radix sort is in computer science. Radix sort is a non-comparative sorting algorithm. It avoids comparison by creating and distributing elements into buckets according to their radix.
Shell sort is mainly a variation of insertion sort. In insertion sort, we move elements only one position ahead. When an element has to be moved far ahead, many movements are involved. The idea of shell sort is to allow exchange of far items. In shell sort, we make the array H sorted for a large value of H. We keep reducing the value of H until it becomes 1. An array is said to be H sorted if all sublist of every H element is sorted. In this sorting algorithm, we compare elements that are a distance apart rather than adjacent. We calculate gap for each pass and then select the element towards the right of gap, and in this case, we reduce the gap by dividing it by 2. Then, we selected one by one elements to the right of gap and place them at their appropriate position. And these are the elements 12, 34, 54, 2, and 3. One by one selected elements to the right of gap and place them at their appropriate position. And we start with a big gap, then reduce the gap. Since elements left of 54 are already smaller, so there's no change. The first gap element, A, and array 0 gap negative 1 are already in gap order, and keep adding one more element until the entire array is gap sorted. Compare 2 with array 3 negative 2 that is equal to 34 and shift it to array gap plus 1 is equal to 3. Since computer start counting to 0 and our array 3 negative 2 is equal to 34, since 3 negative 2 is 1, so our array 0 is 12 and array 1 is 34. Then shift it to array gap plus 1 is equal to 3. For your better understanding, we have all array 4 and we start counting to 0. So our array 0 is 12, our array 1 is 34, and our array 2 is 54, and our array 3 is 2, and our array 4 is 3. Compare 3 with array 4, negative 2 is equal to 54, and shift it to array gap plus 2 is equal to 4. Since our 3 elements is in array 4 and we subtract it by 2, then the sum is 2, and our array 2 is equal to 54, and shift it to array gap plus 2 and is equal to 4. Our next is 3. Since our 3 is on array 2, then we subtract it by 2 is equal to 0. So that our array 0 is 12, and then shift it to array gap is equal to 4. Since now our gap is not more than 1, select all elements starting from array 1 and compare them with elements within the distance of gap. Since our tree is greater than 2, then shift it. Now our gap is reduces to 0. So sorting stops and our is sorted. Heap sort is a comparison-based sorting technique based on binary heap data structure. It is similar to selection sort, where we first find the minimum element and place the minimum element at the beginning, and we repeat the same process for the remaining elements. In this algorithm, we first build the heap using the given elements. We create a max heap to sort the elements ascending order. Once the heap is created, we swap the root node with the last node and delete the last node from the heap. And this is the index input data, the 4, 10, 3, 5, and 1. Now that we have the built-a heap, we need to transform it into a max heap. In a max heap, parent node is always greater than or equal to child nodes. Since 10 is already the largest number and 10 is greater than 4, so we swap 4 and 10. And 5 is greater than 4, so we swap 5 and 4. Then remove the node. Swap first and last node and delete the last node from the heap. In a max heap, parent node is always greater than or equal to the child nodes. Then 4, 1. Remove the node and swap first and last node and delete the last node from the heap. In a max heap, parent node is always greater than or equal to the child nodes. Then swap first and last node and delete the last node from the heap. And swap first and last node and delete the last node from the heap. And there is only one element left in a chip. And this is our sample code creates max heaps on reduce an array.
Sorting algorithm. A sorting stacking algorithms is used to rearrange a given array or list elements according to a comparison operator on the elements. The comparison operator is used to decide the new order or element in the respective data structure.